In this video, let's see how to use the net present value to make a choice between different types of investments. So let's say you have a single project with a set of cash flows of C0, C1, C2, and so on all the way to Cn. Each of these subscripts denoting a year or a period during which that cash flow occurs. So the net present value, or NPV, of these series of cash flows then is the sum of all those cash flows discounted by the interest rate that's applicable for your cash flows, raised to the power of the number of periods. So the first cash flow of C0, which is coming due immediately at period 0, which is right now, is not discounted by anything. The first period cash flow C1 is discounted by 1 plus R, or 1 plus interest rate raised to the power 1. The second period cash flow divided by 1 plus R raised to the power 2, and so on, all the way till the nth period cash flow. And that can be summarized in a compact manner as the sum of, or the sigma of, a series of cash flows ranging from 0 to n, where of Ck over 1 plus R, 1 plus interest raised to the power k. And if this NPV is greater than 0, then you should invest in the project. If not, you should not. Comparing two projects A and B, the NPV of the project A is using the same formula here. It's the net present value of the cash flows of project A, and the NPV of project B is the net present value discounted by the interest rate for the cash flows of project B. And you should invest in project A if the net present value of A is greater than the net present value of B, or you should invest in B if the net present value of B is higher. Now let's take a bunch of cash flows here and actually compute the net present value of these cash flows. So let's say you have a project A and a project B, and we are looking at a 5-year time horizon and a discount rate of 10%. And project A costs $500 to start with, and it yields a steady cash flow of $160 every year thereafter. Project B costs $700 to start with and yields $210 for every year thereafter. Now, if you just were to simply add up the cash flows, if you just were to do a sum of these cash flows, then you will see that project A gives a net positive cash flow of $300, and project B gives a net positive cash flow of $350. So based on the simple analysis, you might want to conclude that project B is a better project to select. But if you do a net present value analysis, you will find something different. So let's do that now. So the net present value analysis will begin by first adding the negative cash flow using the NPV function of Excel of interest rate followed by all the different values. Okay, so that's $106.53, and I'm just going to take this interest rate value here and put dollar signs so I can copy this. And if I were to use an NPV calculation for project B, now you can see that project B gives a net present value of $96, whereas project A gives a net present value of $106. So you should select project A rather than project B. So you can see how just a simple addition of the numbers involved in the project will sometimes give an erroneous answer, but a net present value will give a more accurate answer. I just want to point out one thing here, that in your net present value calculation, the net present value as defined in this Excel function will only compute the present value of these cash flows. The initial cash flow has to be added separately to your formula.